Hi there, this is Srikanth Asare. So in this lesson, we are going to learn about functions with return types. Okay, so let me launch the IDE. So already I have created a project under the name function4 here, which contains a C file, function4.c, and all the basic stuff here. Okay, so to demonstrate the use of return types, or how to return values to and from the function, so let us write a small function sum, which we have seen in the last example. So let us take two variables here first, arguments, which will be used as arguments, and another one to catch the return type. Okay, so we are making just a call to a function which is going to be defined here. Okay, sum int a comma int b. Okay, so this is the function definition, which contains all the basic stuff like this. Just take a C variable and add both the values of a and b, and now to return a value from a function to a main, we need to use this return statement here. Okay, so here you are returning an integer value. Okay, since C is an integer, it holds the sum of both a and b, so you need to specify the return type at the function definition. Okay, at the starting of the function definition. So here, until now in the previous examples, you have used something like this, void. Okay, which means that you are not returning anything. Void implies that the function has nothing to return. Okay, so something like this, and the function definition would be without the return statement here. So here, if you say explicitly int, then you are going then you are saying to the compiler that you are intended to return a value, return an integer value here. Okay, so return C. So what happens here is, if you do function definition like this, return C means it carries the value of C to the calling area, which is main here. Okay, so to catch this return value, we have taken this variable here, res, which means the result. Okay, so if you say something like this, the return value from C gets returned to the calling area, calling section here, and gets stored in this variable. Okay, so now if you want to check the result, you can say, you can just simply output the result variable. Okay, so since it holds the value of the return statement here, so let's have the suite of statement. Okay, so now if you save and run the program, so let's make it a bit viewable. Okay, so here if you see, the sum is 30 and 0 is 0. So why it's getting a 0 here? Oh, we have just skipped the values of a and b here. Okay, now if you save and run the program, so you get sum of 10 and 20 is 30, which is obviously okay. So now the main difference between the previous one and this one is, the previous example, in the previous lesson, we have directly printed the result in the definition itself. Okay, so here we are just calculating some result, and we are returning that value to the main function calling area here. Okay, and you are catching again, you are storing that value in another variable, and just you are printing that. Okay, so in the same way, you can have another function definition here. So let us say here float C is equal to some 1.23, and D is equal to some 3.25, some floating point values here. So again, you can have another function. So if you want, you can have another float D to catch the definition, the value of another function here. Sum of C comma D can do something like this. Okay, so this function holds the sum of integers, and we have written other definition. We have to define another definition, sum of, okay. So another function should have another definition here. So let us say here since we are using a floating point variables and the sum to calculate the floating point values, so obviously the return type of our function will be float, okay. So you can't return an integer when you are intended to do the floating point calculations, okay. So let's just like this define the function float c and float t, okay. So here now you can simply, so in the previous example we have taken another variable here, and we have calculated the result and assigned the value into the variable, and just we are returning that variable here. So all these three steps could be done in a single step here, like this: return c plus t, okay. So if you say something like this, it just calculates the result and returns the value, okay. So always, as we have discussed in the previous examples of our functions, it's always a best practice to have prototypes of whatever the functions you are defining in your example in your program, okay. So always a good practice to have a prototype. So these two are the prototypes of the functions which you are using here in sum and int float sumf, okay. So here so prototype tells the compiler that you are intended to use a function of name so and so, and which contains certain arguments like this and so on, okay. So here you have caught here if you are saying return c plus d, which calculates the sum of the variable c and d and just returns the value and stores, returns means it calls here, okay. It's returns here and just stores in the variable d, okay. So since d is a floating point variable, so here we are returning a floating point value, so we have taken d as a float variable here, okay. So in the same way you can so print the result of the other values, so the sum of percentage f and percentage f. So here you have to say percentage f because you have taken those as floating point variables, c comma d comma cd, and we have made a small mistake here. So let us make it as e, since we have taken d already here in the floating point thing, okay. So e and now cd and e, okay. So let's now save and run the program. So now you get the exact value of the floating point additions here, 1.23 plus 3.25, it's something like 4.48 here. So also you can control those extra zeros, okay. So as we have seen in the previous examples of when we are studying about printf statement, so simply you can control the precision by just adding the up to 2 decimals. If you say 0.2, so your intention is to restrict those. If you observe, so whatever you give exactly 1.23 and 3.25, so you get the same the values here, okay. So functions return types goes like this, okay. So functions with return types, okay. So here in this small program we have taken two functions. Here we are returning in the first one you are returning an integer sum, so that's the reason we have taken the return type as int here. So in the second function definition we have taken float as a return type, so that's the reason we are explicitly saying float in the return type area here, okay. So in the same way, in order to skip these two steps here, okay, so you can directly omit the calling like this here, okay, and you can call your function both these functions, for example. So both the functions within the printf statement itself, okay. So no need to take another two variables here to catch the return values from the function definition. So I have just removed all those things, and directly you can place the calling in inside the printf here, c comma d Okay, so now if you save and run the program, you get exactly the same result. Okay, nothing changes much. Okay, so you can also directly call your function definition, function, can call your function inside the printf statement directly, so no need to take an extra variable and just call and just again use that stored value to print your result. Okay, so this is the basic stuff about functions with return types. So see you in the next lesson. Goodbye.